I'm so excited. No, it's because I have coffee. When I start Unit 7, Trigonometry, and I'm really excited, I drink Dunkin' Donuts coffee. You're not that excited? It's Trigonometry, guys. It's so exciting. Oh, my God. Now you're dying. Okay, so here's the thing. New York State keeps changing. They'll change, and then they'll change, and then they'll change. There used to be a real lot of trigonometry in trigonometry. And then they decided to say, hey, what? Let's not put a lot of trigonometry in trigonometry, and then we'll not call it Algebra 2 trigonometry anymore. We'll just call it Algebra 2. Say what? Common Core. Ooh, Common Core. Makes me shudder. Anyway, so let's do a little bit of trig. Just a little bit of trig. Let's start with some right triangle trig. Now, I call this day 0 because these are kind of some basic notes, which I think you probably already have a pretty good handle on. But if you don't, welcome to Krauseville. By the way, all of these videos in this video series can be found at www.nkinfinity.com. And if you haven't taken the time to subscribe, please do so. Miss Newman and I would very much appreciate it. And stay subscribed to us, please, because that helps us out as well. You know, I'm helping you out. You help me out by just being a subscriber. Every once in a while, if you get bored, or if you want to fall asleep at night, just put on one of my videos. I can't imagine falling asleep any faster than that. All right, let's get going. Right triangle trig. Oh, look at this. We have triangle sun. It's the middle of winter. Triangle sun. The first thing we need to do, we want to find the tangent and the sine and the cosine of n. But before we do that, we probably should find this missing side. Now, yeah, it's right triangle trig. In your brain, you should know that legs squared plus legs squared equals hypotenuse squared, otherwise known as the Pythagorean theorem. Okay, it's Pythagorean theorem, but everybody calls it Pythagorean theorem because who doesn't like pi? I like pi. You know what I like with my pie? Coffee. I like coffee with my pie. All right, enough horsing around. Let's get going. 8 squared plus, we'll call this x, plus x squared equals 17 squared. 8 squared, everybody knows, is 64. X squared, everybody knows, is, just x squared, and this is 289. We'll subtract 64 from both sides, and we get 225, which makes our missing side 15. All right, then. So we know this is equal to 15. Well, now they want us to do these two things. They want us to find sine, cosine, and tangent of angle M. N. Whatever. M&M's. Oh, I like M&M's too. Frozen M&M's are my favorite. I don't know why I'm talking like that. So, let's say we're going to find sine of angle N. And we know sine of angle N to be the farthest side away, 8 over the hypotenuse, 17. We'll talk about these in a second. Cosine of N is equal to the nearest side, or the one adjacent to it, that's not the hypotenuse, which in this case is 15, over 17, over the hypotenuse. And finally, tangent of N is equal to opposite, which is 8, over hypotenuse, or over adjacent, which is 15. All right, so let's get ready to rock and roll. 6 trigonometric functions. 6? Say what? I thought there was only 3. Sine, cosine, and tangent. Well, let me show you a few more. Hit this trig button right here. Look. Sine, cosine, tangent, cosecant, secant, and cotangent. Oh my God, it's so exciting. They're going to add more hard stuff to my math. I long for the days of 5 plus 5. Yeah, I don't know if you looked at Common Core recently, but 5 plus 5 is no longer 5 plus 5. It's 5 plus 4 stacks minus 1 stack. Take the square root of that 1 stack over the 3 stacks plus the 5 stacks plus 2 stacks. Subtract that and get roses. I have no idea. Anyway, some weird math going on. Some of it's pretty cool. Some of it's really weird. All right. So you already know that sine is equal to opposite over hypotenuse. You already know that cosine is equal to adjacent over hypotenuse. And you already know that tangent is equal to opposite over adjacent. Now, if you fail to remember those, let's see, are they on our Common Core formula sheet? Yeah, no, they're not. That's terrible. They're not there. So, what are we going to have to remember them? So, I like to remember them like this. Some old horse caught another horse taking oats away. Now, if you don't like that one, it's because it's pretty lame, you could do some old hippo caught another hippo tripping on alligators. You could do the bad one, which is some old hippie caught another hippie tripping on acid. There are some really bad ones, but we won't go into those. But anyway, it's some old horse caught another horse taking oats away. It's just a simple mnemonic device to remember those. So again, some old horse, some old hippo caught another hippo tripping on alligators, if you like that one better. So let's talk about the reciprocal functions. Now, you all know if I give you x over y, its reciprocal is y over x. Well, these are the three reciprocal functions. The one that goes in conjunction with sine is called cosecant. Cosecant. And it, as it should be, is the reciprocal of this. It is the hypotenuse over opposite. The one that goes with cosine, or is in conjunction, or its reciprocal functions with cosine, is secant. And, I should be saying secant of, what is that thing? We'll have to talk about what that thing is. I'll tell you about that in a second. Is equal to a hypotenuse over adjacent. And the one that goes with, this is secant. And the one that goes with tangent is, as you can imagine, cotangent. And cotangent is, I always have the one get cot. It's cot. Yeah, no, it's not cot. It's cotangent. Don't say cot. Cot's what you sleep on. Cotangent of that weird looking thing, which we're about to talk about, is equal to adjacent over opposite. Now, what is this thing? This is the Greek letter theta. Theta. Say it with me, kids. Theta. Okay, I better take a break, save this, and I'll be right back. At some point, I might use beta. I might use alpha. I might use theta. It doesn't matter. I can do star if I want. Of course, mathematicians try to seem like we're really smart by using these complex looking letters. So most of the time we'll use theta or beta. Every once in a while you'll see alpha. So these are the three: beta, alpha, theta. I feel like I'm going to a fraternity. Beta, alpha. I'm in theta, beta, alpha. What? Anyway, the longest side of a right triangle is definitely called the hypotenuse. The way I find the side that's opposite is I look as far away as possible, and I call this my opposite side. And the one that, of course, adjacent, which means next to, is the one that's next to the angle that's not the hypotenuse. So adjacent is next to, but not the hypotenuse, otherwise known as adjacent. Everybody gets confused with adjacent. So I always start with the hypotenuse, and then I say, okay, here's my angle. Let's go as far away as possible, and we'll make that opposite. And then the one right next to you that I haven't talked about is adjacent. So let's see how this is going to come into play. If sine of theta equals 5/13, find the other trig functions, other 5 trig functions. Well, some of these are going to be easy, and some of these will not be easy. 5/13. And then we're going to do cosine of theta. And then we're going to do tangent of theta. And then we'll do the reciprocal functions. I forgot to mention. Oh my God, I meant to mention this, and I'm so excited about this. This is how much we math people love you kids. You notice that we put sine, which starts with an S, with cosecant. and cosine together with secant. What? They couldn't just put these things together? They couldn't say cosine goes with cosecant and sine goes with secant? That would make so much more sense. No, we don't like you kids. So we decided to make things really, really complicated. Now, honestly, I have no idea who put that together. Mr. Trigonometry someday. I don't know what his name is. You guys can look it up maybe in your history of mathematics course. Clearly, he didn't drink Dunkin' Donuts coffee because he would have made things easier. Remember that, kids. Remember this. We don't like you, so we trick those numbers because you're going to want to say that cosine goes with cosecant because you like putting C's together. That's not true, okay? Sine goes and its reciprocal function is cosecant. Well, we know they're just reciprocal, so this one's pretty easy, 13 over 5. Now, there's a reason I haven't put the other ones together. I don't know what they are. Actually, I do, because I have the notes right in front of me, and because this is such an easy one. And cot of theta. Now, you want to make yourself sound dumb? Say sin. That's for church, kids. Sin. You go to church, you go in the confessional, wherever you go, whatever your religion is, don't care very much. All I care is that's where you go for your sin. When you go for sine, you go to math class. Totally different places. And we're not going to talk about church stuff in school. We're not going to talk about school stuff in church. Just go to church for sin, come to class for math, and sine, okay? Don't sound like a fool and say cot, okay? Cot's what you lay down in and you sleep in the army. Trust me, I know. I slept in a few cots. Tangent, cosine, secant, cosecant. Learn to say the terminology, right? You know, you wouldn't want to say, go to a hockey game and say, what quarter are we in? Quarter? Haven't you ever been to a hockey game before? There's no quarters in hockey. They're called periods, right? You go to the Harry Potter and goes, what's Huffy Puff? No, it's Hufflepuff. What's Gryffindor? No, it's Gryffindor. See what I'm saying? You don't want to say the wrong words because you sound kind of silly. So say the right words, learn them, love them, and learn to love them. So let's talk about this right triangle because I wasn't given enough information to actually answer this question just yet. I got to do some math. Woo-hoo, yes. If you remember correctly, sine is equal to opposite over hypotenuse. So anytime you want to tackle a right triangle trig question, label your diagram. Start with hypotenuse, then go to opposite. Remember, opposite's as far away as you can go. Opposite, and then the one that you're left with is the adjacent side. Oh. All right, so now I can put some stuff in here. Let me go. I know the hypotenuse is 13, and I know opposite is 5. So opposite is 5, and this is 13. Now, I hope at some point you understood this is a 5, 12, 13 Pythagorean triple, but you might not know that. You might not know that 5 squared plus 12 squared equals 13 squared. But I'm assuming you can do the Pythagorean theorem because you've been doing it since like 7th grade. But you should recognize a 3, 4, 5 Pythagorean triple and a 5, 12, 13 Pythagorean triple. Those are the two that are probably the most prevalent Pythagorean triples. There's a bunch more. You saw the one up above, the 8, 15, 17. That's common as well. At any rate, I think I now have enough information, since I now know this is 12, to do the rest of it. So I'll come back over here. Let me finish these in purple. Cosine is adjacent over hypotenuse. And secant is just the flip of that. 13 over 12. Oops. Ooh, forgot to put some legs on my cot. I usually have triangle legs like that. All right. Tangent is opposite over adjacent. 5 over 12. Therefore, cotangent is 12 over 5. Do you see how I was able to use one piece of information, a little bit of math, and I was able to get all 6 trig functions? All righty. So let's do some math after I come back. Okay, kids. Hopefully you had an opportunity to read this problem while I was gone. Oh, I was gone for like 5 minutes. You didn't even know that. Oh, goodness. A stake has been driven on the ground away from the base of a 50-foot pole. All right, so just so you know, all grounds and all poles, I almost said something wrong, form 90-degree angles every single time, all the time. Now, are they exactly 90 degrees? No, of course not. But for math purposes and for all of our purposes, we're going to say that they are. So there's our pole. It's 90 degrees with the ground. So this is the ground. This is my pole. And we got a wire that goes to the top of the pole. So let me draw my wire in. My wire is going to be drawn in. And it's going to be staked down over here somewhere. So it's staked down over there. So the angle the wire makes with the ground. So the angle the wire makes with the ground is right here. And we're going to call that 52 degrees. Oh, there's my doggy. Protecting us from the bad neighbors' doggies. He's so crazy. Find to the nearest... Oh, wait. We know this is a 50-foot pole. Find to the nearest tenth of a foot how far away the base of the pole and the stake should be driven to the ground. So really what they want to know is how far away should we put the stake. So we're looking for x here. Now, before you can solve any of these problems, you need to go through and label it with your opposite, adjacent, and hypotenuse. Always start with hypotenuse. Look for the side that's furthest away, that's opposite. And then whatever's left over is adjacent. Now, then you look for the sides like what I say are in play. What I mean by in play is, do I have a number or am I looking for the hypotenuse? No. The two sides that are going to be in play are the height of the pole, because I was given that it's 50 feet, and I'm looking for the adjacent side. So those are the two sides that are in play here. So why do I need to know that? Well, I need to know which trig function to use. Which trig function am I going to use? Which trig function uses opposite and adjacent? Now, I could use cotangent or I could use tangent, but we only use these when we have to. We only use these when we have to. We really will primarily work with these three over here for now. So, I know that tangent of 52 degrees is equal to opposite, which is 50 degrees, over adjacent, which is x, because that's what I was told, opposite over adjacent. All right, well, how do you solve one of these? Well, you just simply cross multiply. You put this over 1. So I get 50 is equal to x times tangent of 52 degrees. Getting a good habit of putting the trig function second. All right, so I need to still get x by itself, so I'm going to divide by tangent of 52. Divide by tangent of 52. And let's see what we get. Don't need you. Goodbye. Finally need you. Oh, this thing's still going crazy. Escape. All right, so we need to do 50 divided by, so control division, 50 divided by tangent of 52 degrees. And sometimes I hate the way these calculators work. Document settings, we will go with, escape. Approximate. Make default, click OK, hit the up arrow. All right, so the answer is 39.064. I like to put 3 decimals, or 6 decimals. 39.064,281. And they said round to the tens place, so x, or my wire, or no, it's not the wire. X equals 39.1 feet. All right, moving on. Tony Hawk wants to build a ramp for performing skateboard trucks that's 7 feet long, horizontal 3 feet high. So, and he's going to measure it with the ground. Ground is always flat. Here's my 7-foot ramp. There's my 3 feet high. So I've got a 7-foot ramp that's 3 feet high. Find the measure. This is my ramp, by the way. This is the ground. And this is just high, how high it is, the height. So find the measure, the angle to the nearest degree that the ramp will make with the ground. Well, where does the ramp make it? The angle with the ground is right here. So if we don't know that, you can either call it x, but get in the habit of calling it a Greek letter. Almost always we will use theta. All right, so again, we got to figure out which two sides are in play. Let's label those sides first. So we'll label them in green. This is the hypotenuse. This is the angle I'm looking for, so I'll go opposite, goes across, and then whatever's left is my adjacent. Okay. Which two sides are in play? 7 feet and 3 feet. Opposite and hypotenuse. Now, if you go back, sine is equal to opposite over hypotenuse. Remember some old hippie, some old horse, some old hippo, whatever you want to call it. So sine, now sine, cosine, tangent, cosecant, secant, and cotangent all have to have an angle afterwards. So that angle, in this case, is what we're looking for. So we're just going to put sine of theta is equal to opposite, which is 3, over hypotenuse, which is 7. Okay, kids. Wait. Tony Hawk wants to build a ramp for performing that is 7 feet long. I don't like the way this problem is written. Tony Hawk wants to build a ramp for performing skateboard stunts that's 7 feet long and 3 feet high. Oh! All right, this is a poorly worded question. I'm not going to say that this is horizontal. I'm just going to take this out right now. I want a 7-foot ramp. There's my 7-foot ramp that goes 3 feet high. Okay, that's the way I read it. This horizontal, it doesn't make any sense. So we're going to stick with this. It doesn't matter. If you put the 7 down here because you read it the way they read it, that's fine. If you have the 7 down here because I said, I read it, it's a poorly worded question. I'm going to fix that one. It's a 7-foot ramp. That doesn't make sense. Okay, there's a 7-foot ramp. I still need to find an angle. And in order to find an angle, you know how when we had exponentials, where am I writing? You know how when we had exponentials, to solve an exponential, we use logs? You know, if we have a square root, what do? We square it. Or if we have a cube root, then we cube it, right? In order to solve them, you have to use inverse functions. Well, the same is true with sine, cosine, and tangent. You have to use inverse functions. Well, the inverse functions, if you look on the calculator, are down here below. Sine inverse, cosine inverse, tangent inverse. So cosecant, secant, and cotangent. Those are your inverse functions. So what you really need to do is take the inverse of both sides. It's kind of like squaring both sides, but in this case, you're going to take the inverse of both sides because the way to solve a trigonometric function is to take its inverse. So sine inverse and sine cancel each other out. So really what I end up with is theta is equal to sine inverse of 3/7. All right, that's what I'm going to put my calculator. I come back over to my calculator. Trig, sine inverse, 3 divided by 7. Boom, 25.37. So theta is equal to 25.37, 6933. 6933. Round to the nearest degree. So theta is equal to 25 degrees. All right, kids, I'll be back. Ooh, that was awful. So I want you to know that these are some real-life examples. Glenn is standing 45 feet away from the building. When he looks at the top of the building with an angle of elevation of 27 degrees, find the height of the building? What? Okay, whatever. Glenn's got some issues, but whatever. So here's Glenn. Here's Glenn. Glenn's kind of weird. He wants to know the height of the building. Now, he could just look up the blueprints, but in fact, if you don't know the height of a building, it's not like you're going to go to the top and throw a tape measure off the edge. They probably won't let you go to the top. You'll probably get arrested. So it is another way, I don't know what just happened, it is another way of finding out something that, and it's an approximate, but you can use some tools in order to find that height. But we're going to use the math. So we need to find the height of the building, x. And just as before, we need to label it. hypotenuse, opposite, and adjacent. Again, got to figure out which sides are in play. The sides that are in play are adjacent and hypotenuse. Now get in the habit of doing some old horse caught another horse taking oats away, because you're not given those. And what do we need? We're using O and we're using A. O and A is tangent all day long. So tangent, anytime you write the word sine, cosine, tangent, secant, cosecant, secant, and cotangent, you have to write an angle afterwards. An angle has to come later. You can't just leave this blank. You have to have something here. You got to take the tangent, the cotangent, the secant, something. And it's always of some angle. Here's my angle, 27 degrees. And it's equal to opposite, which is x, over hypotenuse, which is, or over adjacent, which is 45. All right, we'll just cross multiply. And I get x is equal to 45 times tangent of 27. Again, get in the habit of putting the tangent trig thing last. It just is in your best interest. So 45 times the tangent of, I have 27, wasn't it 27? 22.9. Let's just leave it. What did I say? Round of the hundreds place? 22.9. 22.92. 93. 22.93. Ooh, my answer key is wrong. Wait, it was 27. 22.93. All right. Let's do, what is it? What? Huh? Oh, shoot. What? I don't understand what's going on. What is this thing called radians? If your calculator's ever in radian mode and you're working with degrees, you're going to get the wrong answer every single time. If you're working with radians and you're in degree mode, you'll get the wrong thing every single solitary time. What is a radian? Well, let's just say this. In order for you to understand this, pi radians are equal to 180 degrees. Now, that doesn't make a lot of sense to me, so let's see if we can talk about this. We're going to talk about this a little bit later when we talk about the circle. This is my radius r. If I lay out this distance right here, and I lay it out along the circle so that it's the same exact length, so that this is r, then if I draw this side in here, so that this is r, and this is r, and this is r, and I create this sector, this angle is 1 radian. Well, isn't pi, just for fun, isn't pi in terms of a decimal 3.14159? So if I do this radian thing a couple more times, like if I do it here, and I get another r, and then I do it here. Now this isn't exact because I'm off by a little bit. Guess what? I get 3.14 radians to equal this of a circle. Well, that of a circle is 180 degrees. So for us, the conversion, or the conversion that we're going to use, is pi radians is equal to 180 degrees. That's our conversion. You know, like 1 mile equals, 1,680 meters or something like that, right? Well, what we're going to use is pi radians is equal to 180 degrees. That's going to be our conversion. Well, okay. When we're dealing with conversions, let's say I had to convert 12 inches to centimeters, x centimeters. Well, okay, so I've got 12 inches. And I want to get rid of inches. So hopefully you've done a little bit with conversion in the past. So if I want to get rid of inches, I'll remember and I'll know that 1 inch is equal to, now this is something you probably don't remember, I believe it's 2.54 centimeters. Now what do I want to show, why am I telling you this? Well, whenever I want to convert, I want to make sure that, oh, this should say inches. These inches are going to cancel with these inches, because that will leave me then my units of centimeters. Well, let's go over to here. I have 60 degrees. I need to get rid of or multiply by something that's going to get rid of degrees. Well, the only way to get rid of degrees is to make that the units down here are going to be degrees. See now, and then on top, if I remember correctly, pi is equal to pi radians is equal to 180 degrees. So now I just cancel this, and I cancel this, and I end up with pi radians, or 60 pi over 180, or pi over 3. This is pi over 3 radians. Let's convert 150 degrees. So we'll do 150 degrees times pi over 180. And if I convert that, I get 150 degrees. Excuse me, the degrees cancel. And I get 150 pi over 180. But that reduces to 5 pi over 6. Woo, what? Negative 45 degrees. Well, it doesn't matter. It's just negative 45 degrees. Again, I want to get rid of the degrees, so I'm going to put 180 degrees down here. I have to get rid of the degrees. So just like with all unit conversions that you're probably doing in chemistry a ton, we're going to put the conversion is pi and 180. Over here, the pi's cancel, or the degrees cancel, and I end up with negative 45, I can never do fours, pi over 180, which is really just negative pi over 4. And finally, 90 degrees. 90 degrees times pi over 180 degrees. It really should come as no surprise. This is pi over 2. And these are all radian measures. We're going to use these a lot when we want to find arc lengths, because they're great for finding arc lengths. Let's convert back. So let's convert back. We're going to convert now from radians to degrees. So now what I want to do is I want to get rid of radians and keep degrees. Now in general, whatever you want to get rid of should go on the second and the denominator of your conversion. So I'm going to take pi over 6 and I'm going to multiply by, well, I want to get rid of radians. So that means I got to put the pi down here. And I want degrees. All right, well, if I do that, notice these pi's cancel. And I get 180 over 6, which is equal to 30 degrees. This should, it depends. This used to become automatic. It's now going to become just a kind of a, all right, do I have a basic understanding of this? Because we're not going to get as in-depth as we used to with this. And so hopefully you can get some, I wish, I don't know if you can tell, I love trigonometry. I wish we could do more of it, but unfortunately, we don't have the time to do it. So we're going to multiply by this conversion. The conversion is 180 over pi. In this case, the pi's will cancel. And I get, well, here's what I like to do. I'm going to say this 2 goes into 180 90 times. So 90 times 3 is 270 degrees. And then I go negative 3 pi over 4 times 180 over pi. The pi's cancel. Now pi is not the units. Pi is just a measurement, because you'll see this in the next one. And if I multiply these out, I get negative 135, I believe. You just put negative 3/4 times 180 and you get, oh, not 134, 135. And then there's this confusing one where there's just negative is still 3. It's 3 radians. Well, let me think about this. Didn't I say a few minutes ago that 3.14 radians is equal to half of a circle? So 3 radians, I'm going to guess, is probably somewhere around 170 degrees, right? Doesn't that make sense? If 3.14 is 180 degrees, right? Isn't this 3.14? is equal to 180 degrees, 3 radians, because that's what this stands for, 3 radians. And I really should have the units here. 3 radians is equal to 180 degrees. Well, what's my conversion? Well, I've got to multiply by 180 over pi. Now, in this case, there's nothing to cancel. So I really need to come over to my calculator and say, okay, 3 times, control division, 180 over, now pi is down here. There. So 180 over pi, hit enter, 171.88 degrees. So 171.887 degrees or whatever. They tell you where to round. That makes sense? And you know, that kind of makes sense. I could just leave it as 540 over pi, right? Because that's what this would be. This is over 1. I could just multiply this out. Or I could say, oh yeah, it's about 171 degrees. So what do you have to remember about this? If your angle, remember, theta is just angles in degrees, you multiply by 180 over pi, trying to get rid of degrees. If you have it in radians, then the radian measure goes on the denominator, and you want to keep degrees, that goes on top. So those are your 2 conversion factors, and those are the 2 things you got to remember to go back and forth between radians and degrees. And you need to start thinking, oh, okay, the easiest way to remember it is pi is 180. So if I said pi over 3, you'd say, okay, pi is 180. 180 over 3 is 60. Oh, that's about 60 degrees. Start thinking about that. If I said 2 pi, well, if pi is 180, then I have 2 pi's. I really have 2 180s. Oh, wait, that's all the way around the circle. And we're going to talk about the unit circle and the unit circle measurements and all that stuff at some point. You'll get there. All right, kids, that ends 7.0. I really, truly hope you enjoyed your time with me today. Sorry it took so long. Catch you on the flip side. Make sure you subscribe. Hit the like button. Don't hit the down button. That makes me sad. Hit the like button.